All right, good afternoon, and thank you for joining us for another Feed and Grain Live webinar, Understanding NEC for Locations with Combustible Dust. I'm your moderator, Elise Schaefer, publisher of Feed and Grain magazine. And our speaker today is Carl von Knobelsdorff, CEO and president of Knobelsdorff. Carl is a self-taught licensed master electrician and holds licenses in 6 different states. Carl serves as principal on an NFPA 70 code-making panel with an emphasis on Chapter 5 special occupancies and hazardous locations. So once again, I want to thank you for spending part of your busy day with Feed and Grain. And without further ado, I'll turn things over to Carl.
Thank you, Elise. Good afternoon, everyone. My name is Carl von Knobelsdorff, President and CEO of Knobelsdorff. We are an electrical engineering and renewable energy contractor serving grain, feed, and flour industries across the U.S. So today we're going to discuss hazardous classified locations and NEC, how we use the NEC to reduce our hazards inside our facilities with good design and installation practices. So today we'll talk about understanding unique hazards in our industry, the NEC hazardous classifications, both divisions and zones, types of ignition sources, NEMA enclosure types and examples of these enclosures, good planning and design to reduce the risk of explosions, and explosion suppression systems. So in the grain and feed industries, we have some unique hazards. We're dealing on the left with a fire triangle. So to have a fire, you have to have a fuel, you got to have oxygen, and you got to have an ignition source. On the right, that is a combustion pentagon. So we also have fuel, oxygen, and ignition, and we also have dispersion of our combustible dust, and then we have confinement. So basically, we have the making of a bomb. So if you look at that pentagon, that's what we basically have in a grain elevator or in a feed mill. We have the enclosed building, which would enclosing our dust. We have the grain dust inside the building, and then we have our potentials for spark and heat. If we have these together at the same time, we got the recipe for a disaster. That's what we try to avoid through good design. So NFPA 70 is a national electrical code. Chapter 5 in the NEC deals with special occupancies. So specifically Articles 500, 501, and 502 is what we primarily will use to do our wiring installations in these facilities. And then we also use NFPA 499, which is the recommended practice for classifications of locations with combustible dust. So in the NEC, we break down our hazardous substances into class 1s, which are gases and vapors, class 2s, which are dusts, and class 3, which is fibers. We further break down these classifications into groups. So you have a class 1 group, a class 1, which is your gas or vapor, and then you break that down into groups A through D, which can be gasoline, propane, acetylene, methane, toluene, methanol, hexane are all different types of gases and vapors that fall into a class 1 location. And each one of those fall into a different group. And depending on that group, you have to use different materials according to that group. So the same type of fittings that we would use for a group A would not necessarily be the same that you'd use for a group D. So you got to be very careful on when you're using materials in these locations to know that you're using the right ones rated for both the right class and the right group. Group E's are metal dusts, Group F are carbon black and coal dust, and Group G's are grains, starches, flour, and wood. So in most of your facilities, if you're in the feed or grain industry, unless you're in some sort of extraction process, you're going to be dealing with Group G locations. So after you know your class that you're in, if you're gas or vapor, or if you're in a dust location, then it goes into your groups and then divisions. So the division breaks down how often your conditions are present in the facility that could cause an explosion. So division 1 location, you're present during normal operating conditions. So when you're operating every day, normal conditions, you have enough dust in the atmosphere that if there was a spark introduced, it could cause an explosion. Most Division 1 locations are going to be in grain receiving, head houses, or inside of equipment itself. Division 2 locations are you don't have enough dust present during normal operating conditions to cause an explosion. So enclosed equipment, good dust collection, generally are going to be rated Division 2. So when you walk into the location, it's good and clean, no dust in the air, that's likely a Division 2 location. The other way we can classify facilities is by zones. So we can use the Division 1 and 2, or we can use the zone classification. So there's two different articles in the NEC on how we classify an area. So division is one way to do it, and the other way is zone. So on the chart here, you can see there's a zone 0, a zone 1, and zone 2, where with divisions, we only have the Division 1 and 2 options. And then you also have an unclassified locations, which would be in your warehouses, office, restroom, break areas. So when we go in to classify an area, we can either use the division or we can use the zone. There's some benefits using the zone classification. It's not used as often. Mainly, you'll see most of your facilities done by the division. So now we got a few examples of some hazardous locations. So a Class 1 dealing with gas or vapor, and then a Division 1 means we're there under normal operating conditions. So gases exist under normal conditions. If you had a Class 1 Division 2, gases or liquids can only be released by rupture or breakdown or failure of ventilation equipment. Now we're in Class 2, so we're dealing with dust, and in a Class 2 Division 1, we have high concentrations of dust present during normal operating conditions. So there's enough dust present under normal operating conditions that if a spark was introduced, you could have an explosion. Class 2 Division 2 location, under normal operating conditions, we do not have enough dust present that could be explosive. So to get an idea of how much dust really is required to cause an explosion and the types of dust and how much needs to be present, you can see on the chart we have sawdust, corn dust, wheat starch, and sugar. So these are all in concentrations. So sawdust, I need 40 grams per cubic meter. That's a concentration that's enough to cause an explosion. Where you see sugar requires 200 grams per cubic meter. Wheat starch is at 30 grams. So wheat starch dust is one of the most explosive dusts that there are. And a good example of how much dust that really is, 30 grams per meter square or cubic meter. If you put your hand out in front of your face and you can't see your hand, that's about how much dust that requires. So you think about that in receiving buildings or inside of equipment, that's where you're going to see those levels of dust. So right there, that picture behind that live bottom trailer, you're standing there that you can hardly see through that dust cloud. That's a Class 2 Div 1 location. So typical facility locations is going to be receiving buildings, bin decks, loadout buildings, anywhere where we don't have good dust collection equipment and the dust is allowed to escape the atmosphere and cause what you see in that picture. So here's another example of where we can declassify areas. So if we have a Class 2 Div 1 location like a receiving building or a reclaimed tunnel, if we add dust collection equipment to that location, we can declassify that area. So instead of it being a Class 2 Div 1 area, we can make it a Class 2 Div 2 area, and now you have less of a hazard and you can use cheaper installation materials and methods because you don't have as high of a risk of explosion. So when we go in to classify an area or a building and we see something that looks like this, I usually like to pack up and just walk right out the door. Right? This is a dangerous situation here, just with the level of dust that you have on top of the equipment. This would cause us to rate this area a Class 2 Div 1 location. And the reason for that is when you have an explosion, usually it starts in a piece of equipment, dust filter, in a duct, or in a bucket elevator, a drag conveyor, and that initial explosion then causes a secondary explosion. And the secondary explosion is caused by all that dust that you see on top of that equipment. That equipment shakes when the first explosion happens. It'll shake the building, it'll knock the dust off the beams, off all the equipment. And once that dust is airborne, it's the secondary explosion that then usually blows the roof or the building apart and causes serious damage. So good housekeeping is one of our best ways to keep a facility safe and not risk secondary explosions. So when we come in and do a classification for a facility, we're looking at layers of dust, 1/8 inch or more. You got a serious issue. You know, it's discernible dust where we can't see paint color anymore. This picture is a really, terrible example of good housekeeping. So now we'll get into the different types of ignition sources that we're looking at when we're rating equipment that can be installed in an area. So once we've identified the class of material that we're dealing with, if it's class 1 or 2, and then the division of the location, if it's a division 1 or division 2, now we have sections of the code that tell us the materials, what they have to be listed for, and what materials we can use in each one of those locations. So part of doing that, the initial hazardous classification study is to tell us what we can do. And we're always trying to make the areas as safe as possible and declassify everything that we can so that your facility is safer and you can use materials that don't have to be rated explosion proof or dust ignition proof. So for motors, motors are looked at under Article 502. And if we're in a class 2 div 2 location, a motor has to be totally enclosed, fan cooled. But there's also another caveat to that they have a temperature code rating that you have to look at on the motor. So you can't just take any TEFC motor and use it in a class 2 div 2 location. You have to look at the temp code rating, and that temperature code rating has to stay under a certain class, which means that the surface temperature of that motor can't get over a certain temperature depending on the group of dust that you have in your facility. Whether it's wheat dust, corn dust, you have to go into Article 500 and 502 and make sure that your T code rating on that motor will work for that location. And this is something that's overlooked a lot when in a class 2 div 2 locations. You know, you have a motor maybe that was initially installed that worked for that location, but then when it gets replaced because it failed, it doesn't get looked at to make sure that it has that right T code rating on it. If we're in a class 2 division 1 location, then we have to use an explosion proof motor. The tag on an explosion proof motor will list the class and division that it can be used in, and it has that T code rating right on it. A lot of times your explosion proof motors also have what they call thermals or P-leads inside of them, which are basically a thermal device that's built into the motor that opens up at a certain temperature rating to make sure that that motor case temperature never rises above that location explosion limit. Control devices are another ignition source. These are looked at in 502.115 and 150. Devices that fall in this category are position switches, solenoids, temperature transmitters. If we're dealing with a class 2 division 1 location, we're going to be using type 7 or 9 NEMA ratings or intrinsically safe. If we're in a class 2 div 2 location, now we're going to get by with types 412. So again, a 7 or 9 rating is going to be a more expensive device versus having a NEMA type 412. So again, if we like to get that rating to that class 2 div 2, just allows less expensive components to be used in your facility and helps make those new projects a little more economical. You'll see in the picture the different types. This is on a bin deck. The picture on the right is a point level transmitter, which has that'd be a NEMA type 7 enclosure, which is a dust ignition proof, could be in a class 2 div 1 location. And on the left is a 24 volt instrument area level transmitter, which is a intrinsically safe device. So light fixtures and general power, area lighting's covered over 502.130. Emergency lighting's covered in the same. Emergency lighting is something that's often overlooked, where they'll spec out to use a class 2 div 1 rated fixture or a dust ignition proof fixture, but then the emergency lighting is just a standard NEMA 1 type fixture. So we see that a lot in facilities where they'll do the facility lighting correct, but they miss the emergency lighting. So both of those have to be rated for the area, depending if you're in a class 2 div 2 and you could get by with dust type, or if you're in that class 2 div 1 and you have to have the dust ignition proof fixtures. Receptacles are covered under 502.145. This is one that's also missed a lot in facilities. They don't make a Class 2 Division 2 receptacle. They only make Class 2 Division 1, which are your twist lock, break, make before break receptacles. So you have to use that type of receptacle in both a Class 2 Div 2 and Class 2 Div 1 location. So there's many feed mills, flour mills, grain elevators that have Class 2 Div 2 ratings that have normal receptacles with weatherproof covers. That does not meet code at all. Why that was allowed to get installed that way, I never could figure that out, but there's lots of facilities that are like that. I think she was gonna ask those. But does somebody have a question, Elise?
Yes, Carl, I was just gonna jump in here. So we have a user who says that in Class 2, Division 2 locations, he has not found hardly any motor malfunctions. Manufacturers that will confirm that their case temps will not exceed the allowable temp of the NEC. We have often had thermistors or temp devices added to the TEFC monitors to assure that the case temp is not exceeded. What is your experience?
I'm going to look at a different computer here so I can see the question. Yeah, that one in our experience is definitely based on motor manufacturer, as well as each motor manufacturer, even by frame size. Sometimes that changes by the different frame size for that manufacturer. So I know we deal a lot with Siemens and Balder motors. Usually your motor rep can get you that information, but if they can't give you that T code information on there, you can't use that TEFC motor. You know, and that's another one that's just, for whatever reason, has kind of been an industry accepted thing that, you know, inspectors won't flag it or won't look, that they'll just accept a TEFC motor. But we definitely could take an email from him and handle that one offline. But usually working with your motor manufacturer, they can get you the T code information on your TEFC motor.
Thank you, Carl.
So another ignition source that we deal with a lot, which is probably one of the most talked about ones, is just powered industrial equipment, right? So your bucket elevators, your drag conveyors, belt conveyors, screw conveyors. And the best thing that we can do to protect from ignition sources on this type of equipment is through hazard monitoring. And there's been a lot of companies with a lot of big initiatives over the last 3 to 5 years, and some even longer, to make sure that all of their equipment has hazard monitoring detection on there. So bearing sensors, alignment sensors, speed sensors, static electricity is often one that gets missed as well, that can affect you on your pneumatic systems and any points of transfer between systems. So if you have not installed hazard monitoring in your facility, and if you have not tested that annually, that is something that you need to get on your list to do. So lots of systems get installed, but then they never actually get commissioned properly or then get tested annually. So in any hazard monitoring system that you have installed, you should be testing annually to make sure that everything is working and functioning and will shut down in case of an event. So. Now we're going to talk a little bit on the different types of enclosures and NEMA ratings and type ratings that you would see in your facility. So we have a type 1 rating, which is for indoor use. Type 3, which is outdoor, watertight, dust tight. Type 4 and 4X, which is indoor or outdoor dust tight. Type 7 is indoor explosion proof, class 1 and 2. And then type 9, which is indoor dust ignition proof, but class 2 only.
Carl, I did have another question come through here.
Okay.
What is your opinion on wires versus cable trays for conduits?
So my personal opinion is any wiring method that's recognized by the NEC for use in a location has been tested by those manufacturers and reviewed by the NEC code making panels to be allowed for use. So I personally have no issue with cable tray in hazardous locations if it's installed, maintained properly. There's lots of opinions out there that conduit with wire is better than cable with cable tray. It is all definitely differing of opinion of your engineering teams as well as operations, right? So cable tray has its own kind of nuances with it. And if people aren't used to maintaining a facility with cable tray and cable tray cable, Conduit and cable might be right for them. It has its advantages on install speed. So it's definitely a lot more cable tray and cable tray cable getting installed now than there used to be. And you definitely see it a lot in Canada and Europe. It's a very prevalent installation practice versus conduit.
Thank you.
No reason we can't use cable tray and cable tray cable in both a Class 2 Div 1 or Class 2 Div 2 location. Just have to make sure you're using the right type of cable. There's just regular PLTC cable, and then there's also an armored tech cable that we can use in the Class 2 Div 1 locations, and then it also has a special fitting that goes with it. So,
thank you.
So on the screen now we got enclosure. This is just a regular set screw type box, which is type 1 indoor use. So this can be used in your warehouses, office spaces, anywhere that's an unclassified non-hazardous location. These come in both painted steel and carbon steel. One thing that you have to watch out for, if you'll see, these boxes have concentric knockouts on the sides of them. So when we're dealing with hazardous locations, we have to do assured bonding all the way back to our service. So what that means is if I have a motor in a hazardous location, I have to have assured bonding, not just using my conduit, all the way back to the service, so all the way back to your MCC room. So you can't just use a conduit, pop out one of these fittings and stick it in that hole. It also has to have a bonding jumper on there and bond all the way back to the service. So that's another thing that we find a lot when doing audits at facilities or doing PMs where the bonding doesn't meet code and was missed during installation. This is a type 3 weather type box. You'll see these installed outdoors a lot, and that's what they're made for. We also see this installed incorrectly indoors in a dusty location a lot of times. This box is not designed to keep out dust. This box is designed to keep out basically water, rainwater. So if you've got boxes like this inside your facility with no gasket, that is an incorrect installation. It is not rated to be installed in a Class 2 Div 2 or Class 2 Div 1 environment. Next, we got type 4 and 4X. So if I got a type 4 box, I can use this in a Class 2 Division 1 and 2 location. The difference there is in a Division 1 location, I can use it as a pull box. I just can't have any splices or taps inside that box. If I was in a Class 2 Division 2 location, I could now have splices or taps in that box. So it doesn't always have to be a box that looks like this in a Class 2 Div 1 location. You can see boxes that look like this. You just have to be cautious what's inside of them. So, and then to make it a 4X, it's the same NEMA rating. It's just a corrosive environment. So it could be either a polycarbonate or a stainless steel. This is a type 7 explosion proof box. We use these in both Class 1 and Class 2 Division 1 and 2 locations. This box here is actually meant, you see all those screws around the outside. It's meant to not keep out the dust and the gas like the other box that we just looked at. It's actually meant to contain the explosion. So if the gas or vapor permeates inside the box and an explosion should happen inside that box, it's meant to keep the explosion inside the box, and it's got a milled surface around the outside edge. And the point of that is so that the heat, as it dissipates out through that surface, by the time it gets out, it's cool enough where it cannot cause an explosion. So a lot of times you'll see this box installed, on the pellet mill floor or down in the basement, and they've only got 2 bolts in there because that's a lot of work to install all those bolts. You need to get those installed because if the reason that they have all those bolts is so that if the explosion happens inside there, it can be contained in there. If you only got 2 bolts in there, they're hand tight. If something does happen, that door is going to blow open, and then you're going to have a secondary explosion. This box here is a type 9 dust ignition proof box. So we'll use this in a Class 2 Division 1 and 2 location. Not as common, but they're cheaper than the big explosion proof boxes that you have in a type 7. So we'll use these a lot in a Class 2 Div 1 location where we're looking to save some money, and lead times on these are a little longer. You don't have a lot of people that stock those. So you got to plan ahead if you're going to need to order stuff like that. All right, so here's a type 3 receptacle cover. So this is a weatherproof, while not in use cover. This is fine outdoors. This is fine indoors as long as it's not in a hazardous location. So this type of receptacle and cover is not rated to be installed in a hazardous location. So if you have any of a normal receptacle like this installed in any class 2 div 2 or class 2 div 1 location, that is not a correct application, and you should get those replaced with a listed receptacle. Now we're looking at some conduit bodies. They make conduit bodies in type 3, 4, and 12. They're designed to keep water and dust out. They can be used in hazardous locations as long as there's no splices inside of those devices. So again, I could use this type of conduit body in a class 2 div 1 or 2 location. Here's another type of NEMA 3 receptacle that's got a weatherproof cover on it. So when the cover is flipped down, that makes it a NEMA 3 rated. Again, that it is not rated to be used in a class 2 div 2 location, because when I open that cover and I operate that switch, I still have exposed contacts and sparking and arcing parts inside there. Here we got a few pictures of some different equipment. You may see this where you've got a mix of type of 4 and 7 and 9 enclosures on the same equipment, which can be perfectly fine by code. So here I've got a type 4 junction box. Just a dust tight junction box that likely has no splices behind there, which would pass in a class 2 div 1 location. Then I've got some NEMA 7 or 9 limit switches, as well as a position transmitter off of a gate, which would need to be listed for a class 2 div 1 and use that NEMA 7 or 9 rating. But the box where I'm just using as a pull box can be rated NEMA 4. There's just a couple more examples of this. Is probably on a door opener, common to see in a receiving building where we got some NEMA 7 explosion-proof enclosures. Now here's that picture of that receptacle. So if you have a class 2 div 1 or class 2 div 2 location in your facility, this is the type of receptacle that you should have installed. This is the only rated receptacle that can be installed in those locations. Example of a 7-9 start-stop switch should be used in a class 2 div 1 location or class 2 div 2. Now here's a motor picture, which kind of goes back to that question that was asked by somebody here a little bit earlier. So this is another tag that you'll see on a motor that's rated for a hazardous location. So this motor you'll see has a class 1 group D or class 2 groups E, F, and G. And it's got an operating temperature code of a T3B. So then here's the other side of that motor nameplate, and it'll have that same information down here on the plate, listed as an explosion-proof motor. And it also shows you in that circle there the P-lead connections on that motor. So that is a Toshiba nameplate. And the next one we'll go to here is off of a WEG motor. So it's each manufacturer lists their stuff a little bit different. Where on this one you can barely read it, but it says T3C there on the code, and then it has it listed as a class 1 div 2 and a class 1 zone 2. So every manufacturer is a little bit different. And again, if you don't know, that's definitely the time to pick up a phone and call your contractor or engineer or the rep for your motor manufacturer and make sure you're using the right stuff. So even on this top of this nameplate, you'll see this motor is only rated, it's rated TEFC, right? But they also have this information on the bottom of the nameplate. So. Lisa, is there a few more questions?
Yes, Carl, I'll start with, what are your recommendations for quickly identifying the ratings on electrical enclosures not equipped with a nameplate?
So no nameplate. It depends if it's just a junction box or if it's on a listed piece of equipment. So if it's a panel board or if it's a piece of equipment on or a panel on a piece of OEM packaging equipment, we would approach that a little bit differently. If it's just a pull box on a wall, if there's no nameplate on it, it's really going to be de-energizing any circuit that's in there, and then you're going to have to open it up and see if there's gaskets on there or if it's non-gasketed. Some of the older stuff is hard if there's no listing on there. We don't know who manufactured it, so you can't go back to figure that out. But there's lots of times where they'll come in and you can have a third party come into, if you're really concerned with it, look it over, third party engineering firm. but a lot of times they'll add gasketing to boxes that have failed over the time. But if you don't have the expertise in your company, it's, we come in and do stuff like that. We definitely can be a resource, or another engineering company or third party company.
All right, thank you. Next question is, which is more used, FM or UL approval?
That probably depends on where you're at in the world. So a UL, I'd say, is a little bit more popular, but it just depends on the manufacturer of who they chose to get their listing done through, whether it was FM or UL or ETL. We just got done with our code making panel 14 meetings this past week, going all over the PIs for the 2023 code. And there was a member from each one of those groups on all those calls. So they're all heavily involved in the industry. I'd say we see a little bit more UL than FM, but you're starting to get a lot of stuff that's dual listed. So
great, thank you.
Any other questions?
That's it for now.
Okay. All right, so when we're looking at design of a new facility or expansion, we're always looking to how to design the facility safely. And we're working with another design build contractor that does feed mill or grain elevator or flour mill construction. Likely they're partnering with another third-party engineering firm, or they have those capabilities in-house. So we work with them. They're working on the facility design to comply with NFPA 61, 652, 654. And then we get involved once most of their design's done to figure out how then we're going to apply all of the NEC codes and 499 stuff in that facility. So some of the codes that they're using are NFPA 61, which is standard for prevention of fires and dust explosions in agriculture and food processing facilities. So they're looking at the facility and structure, the conveying equipment, process equipment, dust system equipment, and ventilation and isolation. They also go into procedures and practices inside the facility, inspection and testing and maintenance, and then training and hazard awareness of the operations of the facility. They'll be using NFPA 652, which covers standard on fundamentals of combustible dust. So this goes and looks at hazard identification, design option, hazard management, including mitigation and prevention, housekeeping methodology and procedures, ignition source control, PPE requirements, explosion segregation and suppression, and dust hazard analysis. So that's a big term that you're starting to hear a lot in the last few years, of getting your DHA done. And have you done your DHA? And there's lots of engineering firms out there that are helping facilities with that and getting that dust hazard analysis done, which then we use that dust hazard analysis information when we do facility classification for their explosion classification for all your electrical and equipment installations. Then 654 is prevention for dust explosions in manufacturing, processing, and handlings of combustible particulate solids. So again, they're looking at storage, material transfer systems, dust collection, vacuum systems, ignition sources, and fire protection. Oh, never mind. So part of that DHA that we talked about, they'll come in and they review the facility for potential fire or explosion hazards and prioritize and generate plans to manage the risk. So really, it's the engineering team comes in and they're going to work with your operations team to review your facility. What are the hazards in your facility, and then what are the high priority things in your facility that they view high risk, and then how do we help you manage that risk? A lot of times this includes adding dust collection equipment, adding explosion isolation equipment, maybe some explosion venting, and usually it's a lot of hazard monitoring installations. So finding indoor bucket elevators that don't have any alignment, speed, or bearing sensors on them, belt conveyors with no hazard monitoring, and getting those things put in place to keep you from having an ignition source cause an explosion. We're looking at new facilities. You get a couple different options on construction, which would be concrete or steel. Concrete usually ends up being everybody's preferred method, but it sometimes comes down to costs that they can't afford to go concrete, so they might look at steel. In a concrete facility, when we have that opportunity, we do a lot of things to help with housekeeping in the long run. So we try to work with the slip contractor to install all of our electrical conduit in the walls. So they'll find a spot in the walls, they'll thicken walls for us so we can slip all of our conduit into the walls of your facility. So you don't have a big conduit rack going up the outside or inside of your building that you have to worry about cleaning around and having dust buildup. They'll use steel tubes instead of I-beams inside on the floors, so you have less ledges. So anywhere you got a poured floor inside that needs reinforcing or beams underneath, they'll use tube steel, or if they do use I-beams, they usually put little plates on the I-beams to keep it from having dust build up on the bottom of the beam. Another option that we do in a lot of facilities is we will embed conduits into the floors. Now, when we do that, we always keep in mind the facilities always change, things are always added, and so we'll do 3D scans of all of our embedded conduits. You always know where that stuff is, as well as we try and keep all of our conduit runs in the walkways, because you're never going to put a spout through a walkway or a piece of equipment in the walkway. So usually feel pretty safe of having conduit installed in those locations. And some facility owners don't like anything installed in the floor, so then we just do everything above or below floor out of our wall boxes. We're looking at steel facilities. There's things we can do there. If you're building a steel mill, we can interior liner panels to conceal all the girts. Again, it's all about easy housekeeping, trying to keep dust buildup on the beams and girts inside your building. So interior liner panels that can easily be sprayed down or blown down, tube steel and solid floors instead of checker plate or expanded metal floors where the dust can migrate between areas of your plant. And also using checkered plate or diamond decking to keep the dirty areas from the clean areas to keep your dust from migrating through your facility. Venting is another important part of new facility or add-ons. Having pressure relief venting on your legs and your filters. Taking your H occupancy areas where you maybe have a hammer mill room or your grinding rooms, and having pressure relief panels out of those rooms and louvers, just being cognizant of where that equipment's getting installed and trying to keep the hazardous equipment that does produce sparks and can cause issues away from personnel. Another thing that's very common today is installing flame arresters and particulate retention vent systems, explosion suppression systems. So on most of the new hammer mills going in, on dust systems that are going in, we're installing explosion isolation systems. So if an explosion does happen, we're containing that explosion to that piece of equipment, and it can't migrate through the facility through the dust collection equipment. So FlameX, BSNB, FIKE, there's lots of different options for these types of systems, but that is a very common thing we see going in now, and we install lots of this on new facilities as well as going back into existing facilities. And part of the DHA identifies some of these issues that may exist, and having installations that don't meet current NFPA guidelines, and then we'll come in and install explosion suppression and venting systems. So another big hazard that exists inside your facilities, not just on the explosion side from having a dust explosion, is just electrical hazards in general. So obviously our company is involved with lots of electrical installs and maintenance, and it's a big deal for us. So you've seen a big change in the industry over the last 5 to 10 years, really, of really being cognizant of NFPA 70E and getting your arc flash studies done. And everybody probably on this call has either had the study done or had somebody talk to them about getting it done, and it's a big deal. So NFPA 70E, like the NEC 70, is all related towards electrical safety. So our NEC 70 is on installations and materials and methods, where NFPA 70E is based on electrical safety in the workplace. So it's all about keeping your people safe when they're working with electricity and around electricity, as well as contractors that come into your facility, as you're the host employer. So there's generally about 30,000 arc flash incidents per year, 7,000 burn injuries, 2,000 hospitalizations, 400 fatalities. 80% of these fatalities are due to burns, not to electrical shock. So when a lot of people think of an arc flash or an electrical incident, they think somebody was shocked, where it's usually that arc flash blast where they get burned and have 2nd, 3rd, 4th degree burns all over their body. And another thing that people think of a lot is, if somebody does get electrocuted, it must have been high voltage. Well, 40% of electrocutions are at 250 volts or less. So it only takes 6 milliamps through your heart to kill you. It does not take a lot of current, and the voltage doesn't have to be very high. So just because something's 120 volt doesn't make it safer from you having an electrical incident. So we're working on design for new facilities, knowing we have to comply with NFPA 70E, and how we look at how can we design this facility to be safer for you to operate and your personnel to operate, and really keep them from having to put PPE on, keep them from having to open doors and test things with meters. And so our goal is to not wear PPE and to keep employees out of harm's way. So we look at that up front when we're designing facilities. So some of the ways that we do that is we just design out the hazard. So you'll see in this picture, there's switchgear on the outside of the building. We do this, you'll see the utility transformer there, which has the highest AIC rating and the highest arc flash incident energy of anywhere in this facility. So we put the main breakers on the outside of the building, and sometimes they'll be in a separate room on the outside of the building because the customer wants them inside. But this way, your high incident energy, your risk hazard category dangerous, isn't even in an electrical room that your plant personnel normally interact with. We also have these mains remote operated, so you don't have to actually stand in front of that main breaker and operate it. We can have a remote switch inside the building that allows you to operate it. We'll use smart MCCs, which basically is just a motor control center that's connected to your HMI or SCADA system. And you no longer have to go into an MCC bucket to check an overload or to check voltage or amperage. We can design this so you can see all of that information from your HMI or from a handheld in that MCC room. So you don't have to have somebody open a bucket to check voltage. They don't have to test a fuse in there. You can see all this information right on the screen. Another thing that we'll do is all of your IO, let's say on a drag conveyor, if you got a plug switch, a slack chain, a speed switch, we wire those inputs back into that bucket, and you can see those on that screen too. So again, you don't have to be in a cabinet with a meter trying to see if something's working. You can see it right from a PLC screen. And then just adding on that HMI and SCADA system, you're using that for troubleshooting and not putting your people in harm's way. So that is all I got. Has anybody got any questions?
All right, thank you very much, Carl, for lending us your expertise this afternoon and putting together a fantastic presentation for our guests. We have a few more minutes to take questions, so if you've been hanging on to them, feel free to use that chat window to enter them now. I do have another question that came through. Carl, how do you recommend conducting an annual hazard monitoring equipment test?
So the way we provide these, as well as there's lots of other qualified contractors and firms throughout the country that do, but what we do is we have an equipment list for that facility. We identify every device that's in that facility, make sure the device has a name, the equipment has a name, and we basically just have a spreadsheet that we use. And then we work with the plant personnel to go out and test each and every device in the facility. And if they haven't ever done that check before, we make sure all the equipment is running and that each device then shuts down that piece of equipment the way it's supposed to. If they have a PLC or HMI system, that when we test that device, it shows up on the screen as the right device and matches the description in the field and the description on the SCADA system. So it's just a methodical approach, a sensor by sensor, piece of equipment by piece of equipment to make sure everything's operating the way it should.
All right, thank you for that explanation. This will be our last question, folks, but as you see, Carl does have his email address there for you to get in touch with him. And the last question that I will ask, similar to the last one, is do you conduct arc flash assessments and what's involved in that process?
Yes, we do. So an arc flash assessment involves, again, if you've never done an arc flash or short circuit study at your facility, basically we come in and we go top to bottom in your facility. We start with the utility. We have to get the incident energy information from them. And then we model your entire facility down to the last piece of equipment. So we collect all the breaker and fuse information. We collect all of your conductor information, including size and length, and all the panel boards, transformers, everything that's going to need a label to meet NFPA 70 requirements. And then we enter that into a software called SKM. And we basically run an analysis on your facility and then print labels and go label all the equipment in your facility that says the incident energy at that piece of equipment. So then when you have to service it or you have somebody else come in to service it, they can just look at that label and it'll tell them what PPE they have to put on if they're going to interact with that piece of equipment. So yeah, that's definitely a service that we provide, and we do a lot of them. And a lot of times what you find is the facility has no documentation at all. So doing that first study is little, it'll cost a little bit more than doing your update every 5 years. So yeah, definitely something we'd be happy to help out with or direct you to somebody that can do that. So.
Excellent. Well, thank you very much, Carl, for your time. Thank you, everyone who was able to log on today. As I had mentioned before, we will be sending a recording of this presentation to everyone who registered, as well as a PDF of the presentation. So with that,
if anybody's got any additional questions, feel free to reach out to us. We'll be happy to help however we can. So.
Well, thank you very much, Carl. I'm sure we appreciate it. And everyone have a great afternoon.
You too.
Thanks.
Thank you.